This is activity 3. I'll take an X, please, from lesson 13. More solutions to linear equations. And I got a little bit out of control on this activity. And so this slide is really for teachers. So what I started to do is look at the standard form of an equation, which is ax plus by equals c, and compare that to the slope-intercept form, which is y equals a negative a over b times x plus c over b. And I started to look at the relationship between these two. So the slope in the slope-intercept form always shows up as the ratio of a to b, but the opposite of that ratio. So a negative a over b. So down here, a negative a over b. And the y-intercept starts to show up as the ratio of c over b. I started thinking, well, why is that happening? Why does that happen that the slope is the opposite of the ratio of a over b? That was really the big one. And then in addition to that, the y-intercept ends up being the ratio of c over b. Well, as you start to manipulate this equation, this form, to the slope-intercept form, you move the ax over to this side of the equation. So that becomes a negative ax, which is also a negative 1 times ax, because you're really subtracting it, or you're adding the additive inverse. So the additive inverse is a negative ax, or negative 1 times ax. So that ends up on this side. And then you have to get y by itself, you divide by this coefficient. The coefficient is b. So divide by that coefficient. So this term with the x variable, the coefficient, it becomes a negative a over b, which is the slope. And does that happen every time? And in fact, it does happen every time. So as I go through this activity, I'm going to point this out. Might be a little bit much for students at this stage, but it's okay. Just take a look at it. And also, I won't make a big deal of this, but the y-intercept is also the ratio of c over b. Now, as I go through this, I should have written this standard form on each slide. I didn't. So you just have to start to remember that the standard form of an equation is ax plus by equals c. And a and b are called coefficients. I don't think that term has been introduced yet. And c is the constant. And we've seen the constant before. This is y equals mx plus b. This is the b, that's the constant in the slope-intercept form. Now, as I did this, I also noticed that there's a bunch of things that students should practice. One is that changing all subtraction to addition using the additive inverse. So I don't really have that right here anywhere, but you're going to see that as I go through the activity. The second is moving terms across the equal sign. As I move this term to this side of the equal sign, it becomes the opposite value. It is the additive inverse of this term. And that's basically what you're doing. To get rid of this term, you're adding the additive inverse. And so then you add that additive inverse to this side. So it's as if, as you move this whole term over across the equal sign, it just takes on the opposite sign. So practice doing that. Doing it both mathematically, where you say that it's the additive inverse, and just procedurally, where you move it over and give it the opposite sign. Switching entire expressions over the equal sign. Sometimes you're going to see equations written as c equals something, or something equals y, and you're going to just want to switch the whole thing. So students can practice taking this entire expression, moving it over to this side, and if they do that, they also have to take whatever expression is on the right side and move it to the left. That's that pan balance idea, where you can switch places. The entire expression can switch places. Now you could go through step by step, adding the additive inverse each time, moving one thing over at a time. You're going to end up with the opposite sign. You're going to have to eventually multiply through by -1 if you do that. And you could do that, but it's a lot. So I would just get I would just practice moving one side of the equation, one expression over to the other side, basically switching them. You don't have to worry about the signs then, and you can imagine doing that. You're just switching places on a pan balance or a teeter-totter. Dividing through by the coefficient. So you're going to have to get used to dividing through, for example, in this case, b. So what happens if I want to get y by itself? How do I divide through by b? And so you're going to want to use problems with numbers and practice dividing through by whatever this coefficient is. So you just have to remember that you have to divide each term. And it's useful to make each of those terms connected through addition, so that when you divide by the coefficient, it's just easier to see if everything is addition. Understanding the coefficient. So understanding a negative coefficient as negative 3x, for example, is really the opposite of positive 3x. So it's a negative 1 times positive 3. So negative 3x is a negative 1, or the opposite of a positive 3x. This will become useful later. And understanding that negative 1 as a coefficient, so negative 1x, we oftentimes write that as negative x, and that's really negative 1x. And right here is a pretty good example. If you recognize that this negative ax is really a negative 1 times ax, it's just easier to see, because eventually you're going to want to see that coefficient when you work with it. And so understanding also that the coefficient of x is 1. So if you just have x written by itself, that coefficient is 1. So I would practice these things. And this might be a little bit too much. I'm also going to graph the equations, and we'll just see what happens. I will put into the PDF or into the video contents, the description below, I'll put a table of contents so you can just quickly click from one place to the other in the video, so you don't have to go through everything. All right, so the first problem, you're going to be 6 problems. Each problem has one card, so students work in pairs. One student has the card that has the coordinates that make this equation true. So these, the x-coordinate and the y-coordinate plugged into this equation, are going to make it true. And so the other student has this equation. And so they're supposed to ask the student with the equation, asks the student with the coordinates, whether they want to know the x-coordinate or the y-coordinate, and then they solve for the other one. And so the student with the equation is supposed to make a strategic choice. Look at this and say, well, what would I rather have? Would I rather have the y-coordinate and solve for what x is, or would I rather have the x-coordinate and solve for y? And this first one's a little bit tough. I look at it and I think, well, if I choose y, if the student gives me the y-coordinate, then eventually I'm going to have to divide by 2, because I have to get that x by itself. And that's not too bad. I can divide by 2. So this thinking right here is what the authors want the student to do, to realize that eventually you're going to have to divide by 2. Or if the student gives me the x-coordinate, so now I know what this value is here, I'm going to have to subtract y. Well, that's a little bit harder for me. I haven't had enough practice on how you deal with subtracting y just yet. So I might ask for the y-coordinate so I can divide by 2, because I know how to do that. And so that's what I did. So tell me what the y-coordinate is. So I'm going to plug that into the equation. So 2x minus, and the y-coordinate is 7, is right here. So the y-coordinate is 7. So 2x minus 7 equals 14. Well, if I subtract 7, to get this 2x by itself, I'm going to have to add that 7 back. So I have to add 7 to this side. So 14 plus 7 is 21. And so I end up with 2x equals 21. And here's where I divide by 2. And that's not too bad. I can do that. 21 divided by 2 is the same as 20 plus 1 divided by 2. 20 divided by 2 is that 10. 1 divided by 2 is that 1/2. So it's 10 5/10, or 10 1/2. And you check it. Yeah, that's correct. So the x value is 10 1/2. The y value is 7. And right here is a little bit of what I was talking about. If you change this to adding a negative 7, And then you add the additive inverse to both sides. Additive inverse of a negative 7 is a positive 7. You end up with 14 plus 7, which is 21. So I would have students practice these different ways of moving through manipulating the equation. All right. So let's change this form to the slope-intercept form. So it's 2x minus y equals 14. I want to get that y by itself. So immediately, this is somewhat difficult. How do you get that y by itself? And if I subtracted y from 2x, then I can add that y back. So this becomes, I'm going to add y, so this becomes y plus 14. I could have written 14 plus y, doesn't really matter. So y plus 14. Now this is a case where if you change this to adding the additive inverse, you're going to add a negative y, and then add the additive inverse to get rid of it. That's a positive y. So you're going to add positive y to this side. So again, a lot of stuff, a lot of possibilities to think about. But now at this point, you're at 2x equals y plus 14. I want to get that y by itself. So I'm going to move the y. I'm going to move the entire expression to this side, and I'm going to move the 2x to this side. And I left that step out. I didn't put that in here. But at this point, I have y plus 14 equals 2x. And if I add 14 on this side, I'm going to subtract 14 to get rid of it. So I'm going to end up with y equals 2x minus 14. Again, I would complete these steps. I'd fill these steps in and have students think through them. Y equals 2x, and here's where I'm going to change it to addition. So I'm going to use the inverse operation and the additive inverse because I want to see what this y-intercept is. And I could get confused if I leave it like this, but if I change it to adding a negative 14, then it's clearly, the y-intercept is clearly negative 14. So that's a lot, just this little bit. There's a lot of stuff going on, and I think this is why students get confused. There's all these little details that teachers skip over, and I'm skipping over some of them right now. And students need more practice on those details. All right, the standard form. This is almost in the standard form as it's written. It's written as 2x minus y equals 14. So if you just use the inverse operation, addition, and the additive inverse, which is a negative y, well, that negative y has a coefficient of a negative 1 times y. So this is where you get used to the coefficient being negative 1 if you have negative y written. All right, so now if you look at the slope over here, the slope is 2 because this is the slope-intercept form. And over here, if you take the ratio of a to b, that's 2 over negative 1, and then it's the opposite of that because remember, you have to move that 2x to the other side, so it's going to become a negative 2x. So this is going to become a negative 2. So you have to take the opposite of this ratio, 2 over negative 1. Well, 2 over negative 1 is negative 2, and the opposite of that is a positive 2. So again, lots of opportunity to get messed up because there's so many negatives running around. And finally, I'm not making a big deal of this. First of all, this is the slope-intercept form, y equals mx plus b. This is the standard form, ax plus by equals c. And the nice thing about the standard form is if you make x 0, then you're going to get y equals some value, and y actually equals negative 14. So that's the y-intercept. So again, if x is 0, you're going to get y equals something. Well, when x is 0, then y is the y-intercept. And when y is 0, you're going to get x equals something. In this case, 2x equals 14, x equals 7. So when y is 0, the x-intercept is 7. So the point 7, 0, and the point 0, negative 14. Both of these points are on the line that is the graph of this equation up here. And also this point is on that line. So now you have 3 different points that are all on that line. You know actually you know one of them right away because that's the y-intercept. That's this negative 14. All right, so let's take a look at the graph. Now, I gave you this as a blank page. You can just copy it off. It looks like this part right here is going to get in the way. In fact, it doesn't when you graph it. So you know that the y-intercept is negative 14, so go over here and go down to 14, put a point there. And you know that the slope is 2. So what does that mean? So that means for every unit in the positive direction, you go up 2 units in the y direction. So if it's 14, negative 14, go over 1, up 2, over 1, up 2, over 1, up 2. And you put points there. And you also know this point. You know it's 10.5, 7. So you go to 10.5, up to 7. And you also know one other point. You know the x-intercept, which was 7, 0. Out here at 7, 0. I don't think I put that one in there. All right, and so this is what it looks like, and I didn't. Here's 7, 0 right here. So you could have added that point, or I could have added that point. So the y-intercept is 0, negative 14 is right here. Add a few more points with a slope of 2. So for every unit in the x direction, you go up 2 units in the y direction. That's what a slope of 2 means. It's y over x, or it's 2 over 1. So 1 unit in the x direction, 2 units in the y direction. 1 unit x, 2 units y. 1 unit x, 2 units y. You know this point, 10.5, 7. You also know this point, 7, 0. So you get this graph. You know that these coordinates make this equation true. You know that the coordinates for any of these points will make this equation true, are solutions to this equation, and that's it. So there's a lot, maybe too much, and I'll try to cut down the explanation as we go through these additional problems. For the B cards, one student is given the equation y equals a negative 2x minus 1/2, and the other student is given the coordinates 0, negative 1/2. And remember, these coordinates are a solution to this equation. So the student with the equation has to ask for either the x coordinate or the y coordinate. In this case, I think it's easier to ask for the x coordinate, because then all you have to do is calculate. If you ask for the y coordinate, then you have to get this x by itself. You have to get the 1/2 on the other side of the equation. You have to divide by negative 2. It just seems harder to me. So I would ask for the x coordinate, and I would solve for y. Also, as we look at this, this is very close to being the slope-intercept form of the equation. The slope is going to be negative 2, but the y-intercept, this is where it's useful to change subtraction to addition. This is going to be adding a negative 1/2. So this is subtracting a positive 1/2. So you can change it to addition by using the inverse operation, and the additive inverse of a positive 1/2 is a negative 1/2. Because if you leave it in this written this way, a student may get confused as to what is the y-intercept. Is it a positive 1/2 or a negative 1/2? But writing it as adding a negative 1/2 leaves no doubt. The y-intercept will be a negative 1/2. All right, so let's take a look. So I said to choose x to calculate, because all you have to do is calculate. And it turns out that it's even better than what I thought, and that x is 0. So negative 2 times 0 is 0, and you're left with y equals negative 1/2. Well, that makes life pretty easy. So y equals negative 1/2, and that checks with the coordinates over here. All right, so let's take a look. This is where I rewrote the equation, the slope-intercept form, but I rewrote it as adding a negative 1/2. So then it's very clear that this negative 2 is the slope, and this negative 1/2 is the y-intercept. Now I want to change this form to the standard form, which is ax plus by equals c. So if I take this 2x and I just move it over to the other side, it becomes a positive 2x. So this is 2x plus y equals negative 1/2. And that's not too bad either. Now remember, algebraically, what you're doing is you're adding a positive 2x to this side. So this becomes 0. So that's the additive inverse of a negative 2x is a positive 2x. And the definition of an additive inverse is that when you add them together, they equal 0. So add a positive 2x, and then you have to add that positive 2x to this side. So this is a positive 2x plus y equals negative 1/2. But when you realize you're just moving this whole term over to the other side of the equation, then you can just simply change the sign. That's a procedural trick, if you will, but be sure to try to understand why you can do that. And you can do that because you're adding the additive inverse. All right, so let's take a look. This is the slope-intercept form. This is the standard form. The slope is -2. So what's going to be the slope over here using this form? Well, it's the ratio of a to b. So that's a ratio of 2 to 1. And remember, the coefficient for this y is 1. So 2 to 1, but it's the opposite of that. So it's a -2. So 2 divided by 1 is 2. The opposite of 2 is -2, and that, in fact, is the slope over here. The y-intercept is going to be this c divided by the coefficient of y, which is 1. Well, -1/2 divided by 1 is -1/2, and that checks as well. Now, why is this -2? Because you're going to move to get the equation in this form with y equals, you're going to move this 2x over to the other side, so that's going to become a -2x. So you realize that it's the opposite of the ratio of 2 to 1, or -2. All right, this is the slope. This is the y-intercept. So on this side, the standard form of the equation, so it's the ratio of a to b, but it's the opposite of that. So the ratio is 2 to 1. The opposite of that's -2, and that checks. And again, if you make x 0, you're going to get the y-intercept. So this is 0 on this side, so y equals -1/2. Well, that makes sense. That's what the y-intercept is a -1/2. And the x-intercept, something useful to figure out. If you make y 0, then you have 2x equals -1/2. So you multiply this 2x by 1/2. That's the multiplicative inverse. It's going to change this to 1, so 1/2 times 2 is 1x, or x, and then 1/2 times a -1/2 is a -1/4. So the x-intercept is a -1/4 when the y-coordinate is 0. All right, let's see what that looks like on the graph. So if you look at the slope-intercept form, the slope is -2. The y-intercept's a -1/2. So you can go down here, place a point at -1/2. A slope of -2 means for every unit in the positive direction along the x-axis, it's a -2 units along the y-axis. So you're going to go over 1, down 2, and you put a point here. Over 1, down 2, and you put a point here. On the other hand, you could go in the negative direction, so it'd be a -1 unit, but then that would be +2 in the y direction, so it'd be -1, +2. So you put a point here, -1, +2, so you put a point here. Connect all those points, and that's the line for this equation up here. And notice I said that this is subtracting a +1/2, so when you rewrite this using addition, the inverse operation, you're going to use the additive inverse of a -1/2. And also, you know this point, which is the y-intercept. You also know the x-intercept, which, if you remember, was a -1/4. Now, I could have made this a little bit easier by expanding this part of the graph, but I just left it as is, and I'm going to show you a couple more points that I placed on here to draw this line. So here's the 0, -1/2, and so -1 in the x direction, +2 in the y direction, put a point here, and a +1 in the x direction, a -2 in the y direction, put a point right here, because that slope is a -2 over 1, or a -2 over 1. Now, if I say, well, what if I go out 5 units? I want a couple more points to be sure where to draw my line. So I'm going to make x -5. So if you go up here to the equation, x is -5, so a -5 times a -2 is a +10 plus a -1/2. So +10 plus a -1/2 is a +9.5. So go over here to 5, and you go up here to 5, 10, but it's a +9.5. So you put a point right there. And what if I go out here to +5? So make this positive 5. So this is going to be negative 10. And that makes sense. Go out here to 5, and then go down, and I'm going to go in the negative direction. So negative 10, but then I also have to add another negative 1/2. So that's going to be a negative 10 and 1/2. So negative 10 and 1/2. So everything seems to make sense as we go through using the slope-intercept form, graphing the equation. Remember that all of these points, the coordinates for all these points on this line, are solutions to this equation. They will all make this equation true, beginning with these coordinates right here, which is where you started. For card C, the equation is 7 plus 5x equals y plus 7. And the coordinates, the x coordinate is 3, and the y coordinate is 15. So now remember, these coordinates, the x coordinate and the y coordinate, are a solution to this equation. So if you replace x with 3 and y with 15, these two sides will be equal to each other. 15 plus 7 is 22. 3 times 5 is 15, plus 7 is 22. So the student with the equation is going to ask for either the x coordinate or the y coordinate. Well, first of all, you can get rid of the 7s. Just ignore the 7s, because if it's adding 7 to one side and adding 7 to the other side, that remains balanced. So you can remove 7 and remove the other 7. So just look at y equals 5x. Well, what would you rather have, the x coordinate and solve for y, or the y coordinate and solve for x? It's probably easier to just ask for the x coordinate, and then you just multiply it times 5, and that's what y is equal to. If you did it the other way, if you asked for the y coordinate, then you'd have to divide this by that 5 right there. So choose x. So y is equal to 5x. I would subtract the 7s first. You don't really have to, but to make it easier, I would. And so replace x with 3. 5 times 3 is 15, so you get y is equal to 15. And so that does check up here. So if x is 3, y is equal to 15. All right, so now let's put this into the slope-intercept form. So which is y equals mx plus b. Well, if you get rid of these 7s, you're left with 5x equals y. So if you just take this, the y, and put it on the left side of the equal sign, and the 5x and put it on the right side of the equal sign, you can go through that algebraically, but in effect, all you're doing is picking each side up and switching places. It all remains balanced, so you just move the y over to the left and the 5x over to the right, and this is the slope-intercept form of the equation. And notice that the y-intercept is 0, because there's nothing here. The slope is going to be 5. All right, so now to write this in the standard form, which is ax plus by equals c, you have y equals 5x. So now you can just take this 5x and move it over to the left side. But if you do that, you're going to end up with a negative 5x. So I would probably move these back and just 5x equals y, and then move the y over. Now, you should probably show each step. It gets a little bit confusing. But in effect, if I move this y over to this side, you're left with 0, and you have 5x minus y, or plus a negative y. Then you can just take all of this side and move it back over here, move the 0 over here, and you're left with this. I'm probably leaving out too many steps and just trying to describe it, but anyway, you get to where you have 5x plus a negative 1 times y equals 0. So this is now the slope-intercept form of the equation. I'm sorry, the standard form of the equation. So if you look at this, slope is 5. Look at the ratio of a to b, that's 5 over negative 1. And remember, it's the opposite of that. So it's going to be the opposite of 5 over negative 1, which is a positive 5. So the slope turns out to be positive 5, which it should. And the y-intercept is 0. So 0 divided by negative 1 is 0. So if you make x 0, then negative 1 times y equals 0. So y equals 0. If you make y 0, you have 5x equals 0. So x is 0. So either way, you get 0, 0. So the y-intercept and the x-intercept is the origin, 0, 0. So to graph these, this is the slope-intercept form of the equation, and you know that one point is 315, and you know that the y-intercept is the origin. It's right here, 0, 0. So then a slope of 5 means that for every increase in x along the x-axis, there's an increase of 5 along the y-axis. So you go over 1, up 5, over 1, up 5. You could also go for every decrease in x, there's a decrease in 5. So -1, -5, -1, -5. And you know that the origin is on this line. This is a proportional relationship, by the way. This is y equals kx. So place a point at the origin, move over 1 in the x direction, up 5, over 1, up 5, over 1, up 5. You get to this point, 315, which is on the line. That's the point that we started with. And also you can move in the negative direction 1 unit and down 5 units. So it's -1, -5. So this is the correct line. Everything seems to make sense. Okay, for the D cards, you're given the equation 3x plus 2y equals 36, and the coordinates are 2, the x coordinate is 2, and the y coordinate is 15. So once again, these coordinates are a solution to this equation. So 3 times 2 is 6, 2 times 15 is 30, 30 plus 6 equals 36. So it makes that equation true. And if you look at this, this is the standard form. This is ax plus by equals c. And so we know from previous problems that the ratio of the coefficient of x, or a, and the coefficient of y, which is b, that ratio, 3 over 2, and then to get the slope, it's the opposite of that. So it's the opposite of the ratio of a over b, or 3/2. So the slope is going to be a -3/2. You can also tell what the y-intercept is going to be and what the x-intercept is going to be from this equation. So if you make x 0, this becomes 0. So now you're left with 2y equals 36, y equals 18. 36 divided by 2 is equal to 18. Likewise, if you make y 0, you're left with 3x equals 36. So x equals 12. 36 divided by 3 is 12. So you have both the y-intercept and the x-intercept and the slope without doing very much work. But let's go ahead and go through this. What are you going to choose? Are you going to choose your partner are you going to choose to get the value of x? Or are you going to choose and solve for y? Or are you going to choose to get the value of y and solve for x? So if you choose x, you're going to have to eventually divide by 2, because you're going to get a number here. You're going to subtract that, move that over here, and you're going to be left with 2y equals something. So you're going to have to divide by 2. On the other hand, if you choose y, then you're going to have to divide by 3. It's because you're going to be left with 3x equals something. So x is going to be whatever's over here divided by 3. Well, for me, it's easier to divide by 2 than it is to divide by 3. So I'm going to ask for x, so that in the end, I'm going to have to divide by this 2. So x is 2, so you're given x. You put that into the equation. 3 times 2 equals 6, plus 2y equals 36. You have 6 plus 2y equals 36. Now you're going to subtract 6 from both sides, or you're going to add a -6 to both sides. Either way, you still end up with the same thing. You end up with 2y equals 36, and so y is equal to 15. 30 divided by 2 is 15, and that checks. Y is equal to 15. All right, so now let's put these equations in both the standard form. It already is in the standard form, so now we just have to move this equation over to the slope-intercept form. So what you have to do is move this 3x over to the other side, and it becomes a -3x. Remember, if you take this whole term and move it to the other side of the equal sign, it becomes the additive inverse of that, because that's what you're doing. You're adding the additive inverse of 3x, which is a negative 3x. That makes this 0. And you add that same additive inverse to the right side of the equation. So you're adding a negative 3x to the right side. So you're left with negative 3x plus 36. Then you have to divide through by this 2. So it becomes a negative 3 halves, negative 3 divided by 2, and also 36 divided by 2 is 18. So you start to see how this up here fits with what you're doing down here. So that 36 divided by 2 is that 18 right there. And the slope is a negative 3 halves. So it's 3 divided by 2. But because it was ended up over on the other side, it's a negative 3 halves. So everything seems to be working. The slope-intercept form, this is the slope. This is the y-intercept. Oh, there should be an x here. I left out an x. Sorry about that. So this should be a negative 3 halves x plus 18. So this is the slope, and this is the y-intercept. So the slope is a negative 3 halves. The y-intercept is a positive 18. Remember, there should be an x here. Using the standard form, we've already done this. This is a negative 3 halves, so it's the ratio of 3 over 2, but it's the opposite of that, so it's a negative 3 halves. And the y-intercept and the x-intercept, if you make x 0, you're going to get the y-intercept. 2y equals 36, y equals 18. If you make y 0, you're going to get the x-intercept. So y is 0, this becomes 0, 3x equals 36, x equals 12. So now I have this point, the point that we started with, and the slope to begin to put together this graph. So over here, this is y is equal to negative 3 halves x plus 18. So here's the x that I left out on the previous page. So 2y equals a negative 3x plus 36. Divide through by that 2. You get y equals a negative 3 halves x plus 18. All right, so the y-intercept is a positive 18. So it's 0, positive 18. Actually, I have the point there already. The slope is a negative 3 halves. What that means is for every 2 units in the positive direction, you're going to go down 3 units in the vertical direction. So over 2, down 3. 1, 2, 3. And you put a point there. Over 2, down 3. Over 2, down 3. Or on the other hand, you could go in the negative direction 2 units and up 3. So then it would be 3 positive units. So for every negative 2 units along the x-axis, it's going to be a positive 3 units along the y-axis. So this would be negative 2, positive 3, negative 2, positive 3. So if we place the point that we know already is 2, 15, so you go down here to 0, 0, it's 2, 15. We already placed the y-intercept. You could go 2 units in the negative direction, up 3 units to get 1 more point. So this is negative 2, positive 3. So with those 3 points, you can draw the line, draw the graph, and it has to go through 12, 0, because this is the x-intercept down here. So it's 12. When y is 0, you're left with 3x equals 36, and 36 divided by 3 is 12. So when y is 0, x is 12. 12, 0, this point right here. So it all makes sense. For the e-card, the equation is 6 minus x equals 4y, and the coordinates, the x-coordinate is 7, and the y-coordinate is a negative 1/4. And here you're subtracting x. That's a little bit odd. It takes a little bit of getting used to how to deal with that. So what are you going to ask for? Are you going to ask for the x value and solve for y, or are you going to ask for the y value and solve for x? Well, I don't want to subtract x. I have to think through a little bit harder how to deal with that. So I'm going to ask for the x value, so I can put that in there and just subtract that from 6. Then I'm going to have to divide by 4, which I think is okay. So what's x? X is 7. So 6 minus 7. So x is 7 equals 4y. So this is where it's useful to change this to addition. So you use the inverse operation, and the additive inverse of a positive 7 is negative 7. So now you can see that 6 plus a negative 7 is negative 1. And so that negative 1 is equal to 4y. And I can also flip this now over the equal sign and get 4y equals negative 1. So you can do that because it's an equal sign. You're just changing the entire right side of the equation and exchanging it with the left side of the equation. So 4y equals negative 1, and y then equals a negative 1/4. You divide by 4. If 4y equals negative 1, then 1/4 of that, 1/4 of a negative 1 is a negative 1/4. And that matches the y coordinate on the card. So it's the x coordinate is 7, the y coordinate is a negative 1/4. All right, so let's put this in the slope-intercept form. So this is a little bit odd to work with. So I'm going to change this x here. I'm going to just put a little positive symbol there because you're subtracting a positive x, whatever, well, positive x. Let's leave it at that. So now I'm going to completely switch the expressions over the equal signs. I'm going to put the 4y on this side and the 6 minus a positive x on this side, but I'm also at the same time going to change this to addition. So it's 6 plus a negative x. So 6 plus a negative x is the opposite of whatever this value of x is. So it's a negative 1 times x. A lot going on here, so you just have to get used to making those steps. You might write those out step by step to take a look at what's going on. So now I have 4y equals, and I'm going to change the order of this using the commutative property of addition. So this is a negative 1x plus 6. That's okay to do. And so now I have 4y equals a negative 1x plus 6. And to get it into final slope-intercept form, just divide through by 4. So that's y is equal to negative 1/4 x. You have to divide this negative 1 by 4. And you also have to divide this 6 by 4. You have to get them to be a common denominator. So 6 divided by 4 is 6/4. So the slope is a negative 1/4, and the y-intercept is 6/4. This is a little bit tough. It takes some practice to go through that. So now let's change this equation to the standard form, which is ax plus by equals c. So I want x on the left side, so it's going to be ax eventually plus by. So I'm going to move this over to the left side. So at first, I'm going to add x to both sides to move the x over here so I can have everything, the x and the y on one side and what will be c on the other side. Now I'm moving this over. The best way to do this is to change this to addition. So it's adding a negative x, and then you add the additive inverse, which is a positive x. That would make this 0, and you add a positive x to the other side. So that's where this x comes from. So 6 is equal to x plus 4y, and then just flip it over the equal sign, put the 6 on the other side. So now you have 1x. I'm going to put the coefficient there of 1. So this is 1x plus 4y equals 6. And so this is the standard form. This is the slope-intercept form. So if you look at the standard form, what's the slope? Well, it's the ratio of a to b, but it's the opposite of that. So it's going to be a negative 1/4. And this is the slope here, which is negative 1/4. So that matches that. So it's the ratio of 1 to 4. I don't really like the way I wrote this. I should not have written negative 1 over 4. Well, but if you're moving the 1x on this side, it's going to be negative 1. And I like it better to just say it's the ratio of a to b, and it's the opposite of that. So this is a negative 1/4 is the slope. The y-intercept, if you make x 0 up here, right here, x is 0, 4y equals 6, y is equal to 6/4. If you make y 0, you get 1x equals 6, which is the same as x equals 6. So this is the x-intercept. This is the y-intercept. So let's see what the graph looks like. So I'm going to use the slope-intercept form. So I'm starting here. I'm putting the 4y on the left side. This is a negative x plus 6 on this side. I changed this to subtracting a positive x to adding a negative x, and this moved it over. So it's a negative x plus 6. And so that is the same as y equals a negative 1/4. Divide through by 4. This is a negative 1 right here, plus 6/4. So now the y-intercept is 6/4. That's 1 1/2. 6/4 is 4/4 plus 2 more fourths is 1 1/2. And the slope is a negative 1/4. That means every 4 units in the positive direction, it goes down 1 unit. So it's 1, 2, 3, 4, and then down 1 unit. So you put a point right here, 1, 2, 3, 4, down 1 unit. Or you could go 4 units in the negative direction, 1, 2, 3, 4, and up 1 unit. That's still the slope of a negative 1/4. Just using the x direction first, which is negative 1, 2, 3, 4, and the y direction, which is positive 1. Also, you can place this point at 7, negative 4. So you go out here to 7, 5, 6, 7, negative 1/4, not negative 4, negative 1/4, so a point right here. So you place all those points. So the y-intercept is 0, 6/4, that's right here. This point is on the line, 7, negative 1/4, so 7, negative 1/4. From here, you can go out 4 more units, 1, 2, 3, 4, and down 1. So this is going to be 10, 11, and 1 1/4. 4 more units, 1, 2, 3, 4, and down 1. So this is going to be 1/4 below this line right here. Likewise, you can go a negative 4 units, 1, 2, 3, 4, and this is a half, a little bit easier to deal with. And so up 1 to the next half, 1, 2, 3, 4, and up 1 unit to the next half. Connect the points, and you get this line. Everything makes sense. And the x-intercept, remember, was 6, 0. So that's this point right here. Because remember, when y was 0, x was 6. We saw that before. Back here. So when y is 0, 1x equals 6 or x equals 6. So this point is also on the line 6, 0. Right here, 6, 0. Okay, the last card, card F, the equation is 9x equals 2y. And the coordinates, the x-coordinate is 4 and the y-coordinate is 18. So once again, put these coordinates into this equation, it will make both of these sides equal to each other. So 4 times 9 is 36, 2 times 18, this 18 right here, is equal to 36. 36 is equal to 36. Can you see that this is going to be a proportional relationship? So this is going to go through the origin. So the x-intercept and the y-intercept are both the same point, the origin, because you're going to get, if you divide by 2 to get this y by itself, you're going to end up with y equals 9/2 x. So y equals kx. So that is a proportional relationship. But I have jumped ahead. So what do you want? Do you want the your partner to give you the x-coordinate, in which you're going to have to divide by 2 to figure out what y is, or do you want your partner to give you the y-coordinate, in which you're going to have to divide by 9 to figure out what x is? Well, I think it's easier to divide by 2, so I'm going to ask for the x-coordinate. The x-coordinate is 4, so it's going to be 4 times 9 is 36. 4 is the x-coordinate. 9 times 4 is 36 equals 2y, and that's pretty easy to divide by 2. So 2y equals 36. Now I'm going to flip these over the equal sign. So I have 2y equals 36 and y equals 18. All right, the y-intercept, the slope-intercept form is, again, I'm going to flip this over the equal sign. So I have 2y equals 9x. And so y is equal to 9/2 x plus 0, by the way. So the y-intercept is 0 and the slope is 9/2. So every 2 units along the x-axis, you go up 9 units, or 2 units in the negative direction is going to go down 9 units. That's what that slope means. And the slope, or the standard form, ax plus by equals c. So I'm starting out with 9x equals 2y. So I'm going to move this 2y over to the other side. So this is going to become a negative 2y. So it's plus a negative 2y. And since I moved that over here, I'm left with 0 on the right side. Now, if you change this to 9x, no, I'm sorry. If you just add the additive inverse, so the additive inverse of 2y is a negative 2y. So add the additive inverse to this side, that equals 0. Add the additive inverse of 2y, which is a negative 2y, once again to this side, you're going to get 9x plus a negative 2y. I think that's a little bit easier way to see it. So this is now the standard form. 9x plus a negative 2y equals 0. And where does the slope come from? The standard form is the ratio of a to b, so that's 9 over negative 2, but then it's the opposite of that. So it's going to be a positive 9/2, which is what the slope is over here. And we already know that the y-intercept, if you make x is 0, you get negative 2y equals 0, y equals 0. If you make y is 0, you get 9x equals 0, x is 0. So this goes through the origin. 0, 0. This is the slope, it's the ratio of a to b, 9 over negative 2, but it's the opposite of that. So the opposite of a negative 9/2 is a positive 9/2. So the slope is 9/2 once again. And that checks with over here. The slope is 9/2. All right, a graph of this. You know that the point 418 is on this line, so you could go out 4 and up 18, 15, 16, 17, 18. You know it goes through 0, 0. This is a proportional relationship, and the slope is 9/2. So you can start at 0, and for every 2 units you go in the positive direction along the x-axis, you're going to go up 9 units along the y-axis. That's what a slope of 9/2 means. So 2 units along the y-axis and 2 units along the x-axis and 9 units along the y-axis. So go over 2, up 9, put a point here. Go over 2, up 9, put a point right here, which is at 18, by the way. Over 2, up 9, over 2, up 9. This is 5, 6, 7, 8, 9, which is 18. All right, so now you can graph it. Goes to the origin, 0, 0. One of the points is 4, 18. And another point, just to make sure, is this point where that's 2, 9. And you get that from the slope starting, and you have to start with a point that's on the line. And one of the points that's on the line is 0, 0.